Hi, this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. Well, this is the last video of this course. Congratulations, you've made it to the end. In this video, I am going to look at some new technologies in deep learning that are just coming onto my radar for possible inclusion into the class. I always modify this class as new technologies come out, so be sure to subscribe so that you stay up to date with new videos as I put those out. I actively put new videos on new technologies all the time onto this channel. To see all my videos about Kaggle, neural networks, and other AI topics, click the subscribe button and the bell next to it and select all to be notified of every new video. So let's get into the top 3 technologies that I'm particularly interested in. There's many technologies that I am interested in, like capsule networks, or one that almost made this list, but more just keeping them monitored. These are 3 that are close to the top of the list where I would potentially add them to the course. First, we'll look at neural structured learning. This is how you add graph type data to the inputs of the neural network for training. We'll look at some of the really advanced natural language processing options out there, Bert, Albert, and other related NLP technologies. And we'll look at explainability frameworks. We'll start with neural structured learning. So neural structured learning, what this really does for you is gives you a way to input graph data into the training of the neural network as well. This is used very often if you have, say, a bunch of images that the user has already done some tagging on, maybe put them in specific albums, other things like that, or if you have multiple images that you know are close together in some way, shape, or form, you can put these graph edges into it, lines, and connect them. Now there's 2 primary sources that this additional graphing data comes from. And the graph data, this is only used during training. You don't use this when you score. It gives it a way to train the neural network much better with less data. So one way is just existing graph relationships in the data. If you, for example, had pictures of people and you were using LinkedIn data, you've got a clear graph right there. Who has connections to who? The other very interesting area that NSL is used in is automatic adversarial modification of images. So this lets you help make your neural network a little more resilient to these adversarial example attacks. Basically, you create your own adversarial examples and send them in along with your training data, but you link those new training examples that you have back to the original one, and those connections, those links, become the additional training data that it learns off of. And it's all generated. You don't have to actually have any graph relationships in your data. Now, the NSLs are built into TensorFlow 2.0, but you do need to do a pip to install it. So you do a pip install neural structured learning, and now you have access to these, and you can incorporate them into the graph going into the neural network, and that allows you then to give this additional data to train your neural network better. So this is very good if you want to either incorporate those adversarial example attacks, or if you just have inherent graph data that you want to add to your training set. I have a little more information on it here, and I'm just giving you a high level of some of the things that I'm thinking of putting into the class. Now, any of these, if I did put them in, I'd probably have an entire 15-minute video just for each of these. Now, how does NSL help? You can see here the green is the graph. And by the way, the graphs are put in a lot like regularization. So you can add these graphs to the training data of just about any type of neural network that Keras supports. This number at the bottom tells you how much training data that you've had. And these are 2 different architectures of neural network. And you can see at this specific type of training data, when you don't have nearly as much smaller numbers, the graph-based regularization, so the one with the neural structure in it, is outperforming the other. On all other cases, it really doesn't matter as much. So this is just a way to get additional information into the training so that you can train better My real interest is using this for the adversarial example attacks, where you're adding in examples that have been modified, but you're also putting in that structure so that you can link those to the actual correct one. Okay, the other one that I'm really interested in is Bert, Albert, and other natural language processing technology. This is one that I am actively looking at myself right now. This will almost certainly find its way into the class. This is one where Google often touts that they have achieved state-of-the-art results. I find that very interesting. What is state-of-the-art result? Well, the way Google talks about it is you have these 3 benchmarks here. These are almost like Kaggle competitions. Glue is the one we'll take a look at in this overview, but if you look at Glue, it's a lot like a Kaggle. You've got a leaderboard, which here shows you which algorithms have done the best. Up to just a few weeks ago was Albert, but now there's another entry from Google, the T5 entry. It's not getting a tremendous amount of gains on the overall score, but this is showing you basically which algorithm is achieving state-of-the-art results. Now, all these other columns here, these are individual tests that we'll look at right now to get an idea of what this training metric is really measuring. So we'll look mainly at Glue. We won't look at these others, but I've got the papers and I've got the links to their site. Now, if you look at Glue, what Glue is a collection of metrics. And each of these tests that you have here test something differently about the natural language processing. So let's look at the single sentence task. That is COLA and SSH2. These are the first 2. For COLA, what it is doing is evaluating the English grammar. So the training data came from English grammar books where they show you acceptable and unacceptable usage. So acceptable usage is the angrier Sue gets, the more Fred admires her. That's grammatically correct. Ungrammatically correct is the most you want. The most you want, you would say maybe the more you want. So this is showing if the neural networks have the ability to detect bad grammar. SST2 is used to do sentiment analysis. So a positive sentence might be this one, the greatest musicians. A negative lends some dignity to a dumb story. So definitely negative, definitely positive. And if you look at the training data, it is based on the degree to which it is one or the other. Now your multi-sentence tests, that's MRPC, QQP, STSB. This is looking at, so the MRPC, the first one, is looking at, are the 2 sentences equivalent? He told the newspaper that Miss Hussein's daughters had British schools and hospitals in mind when they decided to ask for asylum. Saddam's daughters had British schools and hospitals in mind when they decided to ask for asylum, especially the schools. So those 2 sentences are really doing sort of the same thing. Now these 2 look similar, but they're not equivalent. Georgi Heisler, the head of the local disaster unit, said the coach was carrying 38 passengers. The head of the local disaster unit, Gori Hetzler, said the coach driver had failed to heed the red stoplight. This is giving you some more information, but these 2 sentences are not the same. QQP is Cora question pairs. These are looking at, are 2 questions asking the same thing? What are the coolest Android hacks you know? What are some cool Android hacks? So these 2 are equivalent. If you receive a check from Donald Knuth, what did you do with it when you got it? How can I contact Donald Knuth? Those are 2 completely separate sentences. By the way, I know actually what they're talking about. Donald Knuth, if you found an error in one of his books, he would give you a check for $1.28. Well, Donald Knuth is so famous, nobody hardly could bring themselves to cash those checks. People would often frame them or something such as that. I mean, he's the father, essentially, of computer science by many accounts. STSB evaluates how similar 2 sentences are. This would be 0. A woman is dancing, a man is talking. 2 sentences with a higher label, a plane is taking off, an airplane is taking off. These 2 are very equivalent. Okay, those are just comparing the similarities of sentences. There's also inference tasks. This looks at doing some inference on sentences and asking questions about those. We had the MNLI, QNLI, RTE, and WNLI. The MNLI provides the 2 sentences and they're labeled either neutral, contradiction, or entailment. These are a contradiction. At the end of the Rue des Franches is what many consider to be the city's most handsome residential square, the Place del Vesogros, which is stone and red brick facades. Place des is constructed entirely of gray marble. Okay, this contradicts. These two sentences are entailments. So I burst through a set of cabin doors and fall to the ground. I burst through the doors and fell down. They work together. Two sentences that are neutral are given here. The QNLI test poses a question for supporting a sentence. It's either an entailment or not an entailment. So the first one is not an entailment, which missile batteries often have individual launchers several kilometers from each other. And then these look similar, but it's really not an answer to this question. When MANPADS is operated by specialists, batteries may have several dozen teams deploying separately in separate sections, self-repaired air defense guns, and many deployed pairs. That's an answer to something, but it's not an answer to that first question, even though they're somewhat similar. These are entailment, so what two things does Popper argue Tarski's theory involves in an evolution of truth? And then the answer, he bases the interpretation on the fact that such examples, such as one described above, refer to two things, assertions and the facts to which they refer. So that is an entailment. That is an answer to that question. The RTE task looks at whether one sentence entails another. So not as questions and answers like the one before, but the first one that is an entailment, Lin Pao, after all, was the creator of Mao's Little Red Book of Quotations. Lin Pao wrote the Little Red Book. So yeah, those kind of go together. Ones that are not entailments would be oil prices fall back as Yuko's oil threat lifted, oil prices rise. The W&L task checks to see if two sentences agree to a third. For example, the foxes are getting in at night and attacking the chickens. They have gotten very bold. These agree. The foxes have gotten very bold. These do not agree. Sam pulled up a chair to the piano, but it was broken, so he had to stand instead. The piano was broken, so he had to stand instead. A lot of similar words, but they do not agree. They're playing with the pronouns and what pronoun is attached to which actual noun. So Bert, how does Bert do this? How is it able to be used on all those different tests that I showed you and get state-of-the-art results? Bert uses two things before you even try to score a sentence with it. It uses pre-training and then it uses fine-tuning. Pre-training is shown in this diagram here. This is essentially using something called a generator, which is pretty interesting in its own part. This generator is able to take existing sentences and predict what would complete them. So here we're training it on two things, really. We're training it on, can it fill in data between two sentences, and can it fill in missing words in a sentence? This is the pre-training. This was done by Google, and you can simply download the pre-training here. Fine-tuning is when you take this pre-training, which hopefully only has to be done once per language, and you fine-tune it to a specific task, like MNLR, NER, and SQUAD, all these different evaluation tasks that it has. Then once you've trained it for what it's classifying, you've got like the two sentences going in, the one sentence, and you've got it mapped over to the target, you put the data in like this, and it comes into the inputs of the, as a sequence, kind of like you do in LSTMs, but it's not really using an LSTM, it's using a generator. And you send in all this information, and it calculates the token embeddings, segment embeddings, and position. So this is the true, I'm not going to go super deep into this, but this is just, I'm just going to look at this at a high level. This is just showing you the data actually going in after you have fine-tuned it. So you download the pre-training, then you fine-tune it for your task, and then you can present the data into it. Finally, I just want to let you at least know of explainability frameworks. LIME is particularly interesting. It can work with both tabular data as well as images. It shows you what part of the image, what part of the table is actually being used. Explain It to Me Like I'm 5 uses LIME and a bunch of other things, and it produces this really sort of graphical report to show you why the neural network is not being a black box and actually give you some insight into why the neural network predicted what it did. Well, we've come to the end of this course. Thank you for watching all of these videos and making it this far. Like I've said before, please subscribe to the channel so that you can stay up to date with new technologies as I add them. Thank you for watching these videos, and I hope you've enjoyed this course.